There is a huge problem in space right now and no one is talking about it. Space junk is filling our atmosphere, and if we aren't careful, it could literally trap us on Earth. This is Earth today, surrounded by 7,560 active satellites. There is already a significant amount of space junk in orbit, but it's about to get worse. This is our Earth 26 years in the future. By 2050, it's predicted there will be more than 500,000 active satellites in orbit and hundreds of millions of pieces of space junk. If we aren't careful, this could lead to us being stuck here on Earth, as flying a rocket through the debris would be too risky. In 1957, we began reaching for the stars, launching satellites and rockets into space for the first time. Since then, we've delivered over 14,000 satellites into orbit and had 6,300 successful rocket launches. This is obviously great, but it comes at a cost. There have been more than 630 explosions, collisions, or other unplanned events causing our spacecrafts to be destroyed in orbit. And this creates space junk, millions of small objects orbiting our Earth at 28,000 kilometers per hour. That's quick enough to travel from New York to LA in just 8 minutes. There are currently 36,500 objects larger than 10 centimeters in size, 1 million objects between 1 and 10 centimeters, and unbelievably 130 million objects between 1 millimeter and 1 centimeter in size. These objects could be anything from satellites and rocket fragments to even tiny specks of paint. And while these tiny pieces may seem harmless, when they are accelerated to be moving at 8 kilometers per second, they can cause some serious damage. The satellites in low Earth orbit help control our TV and internet services, as well as GPS and weather monitoring. They are imperative to everyday life here on Earth, and are now at risk. And there are some really serious objects up there ready to do some damage. More than 1,000 upper stages from rockets are currently orbiting the Earth. These are hunks of metal bigger than a school bus, traveling at thousands of kilometers per hour.
It's a huge concern. It's a very, very big problem.
The thing that particularly worries me is that this is just the beginning.
In 1983, the Challenger space shuttle returned to Earth with a cracked windshield. Engineers assumed it was caused by a collision with a micrometeorite, a tiny piece of cosmic dust that could have collided with the spaceship. But after further examination, it became clear that Challenger actually encountered something man-made. A paint fleck just 0.3 millimeters across hit the windshield at 4 kilometers per second, creating the deep crack you can see here. And it happens pretty often now. This is a crack in a window on the ISS caused by a similar paint fleck. Imagine if it had been a larger piece of metal, or if instead of hitting a window, it hit an astronaut on a spacewalk.
It's like about 1 millimeter in diameter. It's really small. And he looked at that and he said, man, if that hit one of us. And he didn't have to finish that statement. It could be a fleck of paint hitting you at that velocity. If it hits you in the suit, you're in a 100% oxygen environment. And you're just going to flame up. I mean, you're going to instantly combust. It's going to be really a bad day.
In 2009, a US commercial Iridium satellite collided with an inactive Russian communication satellite. It was the first time 2 spacecraft ever accidentally collided in orbit. And the crazy thing is, the Russian satellite wasn't even in use. The entire event could have been avoided if it were decommissioned and burnt up in the atmosphere. These are all the currently active satellites in orbit. 7,560, and these are all the dead satellites. They are not being used for anything and are simply orbiting the Earth, waiting to be burnt up in the atmosphere. Nearly 50% of all satellites in orbit are dead. The current rules state that any dead satellites need to be deorbited within 25 years, meaning companies and countries could just leave their space junk up in orbit for a quarter of a century, no problem. And this debris doesn't just pose a threat to our satellites and rockets. As pieces of this space junk re-enter the atmosphere, most of them are burnt up, but the larger pieces can make it all the way to the ground. Just 2 months ago, a mysterious object crashed through the roof of a home in Florida. Turns out it came from the ISS. And it's not just small objects either. this piece of a SpaceX rocket washed up on the beach in the Bahamas. In 2019, this rocket was launched by China to carry navigation satellites into orbit. The first stage separated as it was meant to and then fell back to Earth, tragically landing on someone's home. This has happened many times before in China. As companies like Starlink and OneWeb continue to launch these huge satellite constellations over the coming years, the number of satellites in our orbit will skyrocket from just a few thousand to a few 100,000. This will lead to a future where our orbit contains millions of extremely dangerous pieces of space junk and potentially billions of small pieces capable of destroying our satellites. Low Earth orbit is already a crowded environment between the current satellites and our growing population of space junk. This is why the future is starting to look pretty scary. If things keep getting worse every year, we really could be trapped here. As the number of objects in low Earth orbit increases, the likelihood of collisions goes up too. This would eventually lead to Kessler Syndrome, first proposed by Donald J. Kessler in 1978. These collisions would lead to a cascade effect where each one creates even more pieces of space junk, leading to further collisions. If this happens, we would truly be stuck here on Earth. Rockets looking to fly out through the space junk would likely result in collisions, leading to near certain failure. But hold on, this depressing future of us being trapped on Earth with no satellites and no way to leave is not guaranteed. If we do nothing and continue to launch more and more satellites, sure, it will become likely. But I'd like to say I'm relatively confident that won't happen. We have at least another few decades before the issue could become really serious. By 2030, our satellite numbers in low Earth orbit is expected to still be 6 times greater than today. That will come with consequences for sure. But this has me wondering, even if we somehow, say, fix the space junk problem, how will all of these launches and all these new satellites impact ground-based astronomy? Will our observatories on the ground be able to observe anything anymore, or will they just be ruined by new satellite constellations? Something you need to keep in mind is telescopes like Hubble, maybe the most influential telescope ever built that first gave us this view of the deep universe. These telescopes orbit in this environment around the Earth where they are in danger of collisions themselves. But what about the telescopes on the ground? As we continue to launch more and more satellites, this becomes a reality for our observations. Streaks of light reflected by satellites, mostly Starlink, blocking the observatory's observations. There is a telescope in Chile being built right now, the Vera Rubin Observatory, that will revolutionize astronomy when it starts operation later this year. It will conduct a 10-year survey of the southern sky using its 3,200 megapixel camera to image the entire sky every 3 to 4 nights. This is what Vera Rubin would see in today's skies. There would be the occasional streak across the images caused by a satellite moving across the sky, but most of the data would be clean. Over time, as more and more satellites are launched, more of these streaks will appear in the images until they are unavoidable. Once we have 100,000 satellites in the skies, every single image will have at least one satellite streak across it, blocking our view to the most distant objects in our universe. So I guess the question really is, how do we fix this problem? And there are a few options being explored right now. The main goal is to slow down the debris just enough so it falls down into the atmosphere and burns up. For the large pieces of rockets and satellites we can track from down here on Earth, space companies are currently developing spacecraft that will essentially grab a hold of these objects and slow them down. They can do this with huge nets or even hooking onto them and dragging them down into the atmosphere. But these smaller pieces present a whole set of different challenges. I mean, we can't exactly easily capture 130 million tiny flecks of metal and paint orbiting that quickly. Ideas like huge sweepers that would collect them all like a street cleaning machine have been proposed, but NASA have said that this option is just too expensive. So it's really still up in the air how we might deal with these tiny little pieces. And here's my favorite one. Companies are currently exploring the idea of using lasers to shift the orbit of space junk pieces between 1 and 10 centimeters in size. They could use the lasers to either push the objects down into the atmosphere where they would burn up, or up higher where they're at less of a risk of colliding with satellites. There are a number of companies around the world developing this technology right now. So if you want me to go visit one so I can show you how space lasers really work, let me know in the comments.